So, what I really want to remind ourselves here is the importance of some trig identities when it comes to integral calculus and just calculus in general. And those identities, they might be maybe Pythagorean identities or half angle identities, or it even might be product formulas, or in this case, the ones that are really going to help us, the double angle identities. So, um, it how we use them, it all depends on the type of function that we have, and of course in this case we are focusing our attention on trigonometric functions. Okay, so this might be a bit be of a challenge to integrate this the way it is. We might want to change it in a different form so that we make the integration process much easier and fun. Okay, so these are the double angle identities that we have, and the double angle identity that I'm going to focus on is the second one, which is this one here. Okay, it's the second one. So what it is here is that I'm just going to pick this part. Then from there, we're going to understand how we are going to utilize it to come up with this. And if you observe, here we're using theta, here we're using t, or in this case we're using 3t. So this could have been like sine squared t, but we're using 3t. So what I'm going to do is that I'm going to try to pick it up from just a t as the angle. Then we're going to use the understanding that we're going to get to also work out what when the angle is 3t there. Okay, so what it is here is that it what it basically means is that if I'm to use t, all I'm saying is that I have cos I'll have cos 2t, okay, being equals to uh, cos squared t minus sine squared t there. Okay, minus sine squared t there. So what you observe is that our sine squared, our sine squared of theta, sine squared of the angle is the one that we are supposed to make the subject of the formula. Okay, so how do we then do it? We might need the help of Pythagorean identities, one of the Pythagorean identities, which is it's more like this. We have cos squared t plus sine squared t is going to be equals to what? Is equals to 1. We might need the help of that. So since I'm trying to make sine squared t or sine squared theta the subject of the formula, I need to change this. I need to substitute there with something. So here I'm going to make my cos squared t the subject of the formula for this Pythagorean identity, which is just going to be equals to 1 minus sine squared t there. So it basically means my cos 2t is going to be equals to 1 minus uh, sine squared t there minus sine squared t like that. So we're going to have cos 2t here being equals to 1 minus that's going to be a 2, that's going to be a 2, um, that's going to be a 2 sine squared t like that. So we have to make the sine squared t, or let me just call it sine squared theta, to be the subject of the formula. So this is just going to be, I'm going to have 2 sine squared theta. This might confuse someone. Let me call it a t though it is. Yeah, sine squared t is going to be equals to 1 minus 1 minus cos 2t like that. So you divide both sides by 2 like that. That goes and that goes. So we have our sine squared t being equals to 1 minus cos 2t divide by what? Divide by 2 like that. Okay, so this what the outcome that we have right now is very 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 important. It's very very important. Yeah, so what it is that if you observe here, what you have is not sine squared t. What you have is sine squared 3t. Okay, so what it means here is that if I come here and say, okay, if I have this, if I have sine squared t to be equals to that, what could be sine squared 3t? Okay, how can we put it in short? So this is just simply going to be equals to, you're still going to have a 1 here minus uh, cos. This part here is what is going to change. So keep in mind to say when you have a t, this is equals to what? This is equals to 2t. So when you have a t here, this side you're going to have what? A 2t there. The same as if you had a theta here, this side you're going to have what? A 2 theta. So it basically means if you have 3t, this side is going to be what? Just going to be 6t. Okay, so here you're going to have what? 6t there. Divide by divide by 2 there. All these processes that I'm going through, they might appear to be unnecessary, because at some point you're going to become very familiar with such things, such that immediately you see, for example, if you put a 4 here, okay, if here we put a 4, it basically means here this is just going to be what? 8t. Okay, so all this you will not need to do it. You don't need to show it anywhere. I'm just trying to like remind ourselves of how it comes about, how we write it in a certain way to simplify it for ourselves to work with. Okay, so this is basically what we are going to use, and you might also want to see it in terms of like these being these that we have here, the double angle identities being the just having angles. It basically means in some way, okay, in some way, this that we have right here, okay, that we have right there is more like from this Pythagorean identity. I'm not going to write this Pythagorean identity like that. I'm going to write it as cos cos squared 3t plus sine squared 3t being equals to what? Being equals to 1. So you observe to say, as long as I've maintained the angle here, the outcome is still the same. It's still going to be a 1. That is the uniformity that we have at this point. We have a 1 and we have a 1. We have 1t there and 1t there. The angle is the same. So you're going to have a 1 here. So as long as you keep the angle here and the angle here the same, the outcome is still a 1. It doesn't matter how big the angle is. I can say infinity t or something like that. As long as they are the same, it's still going to be one and the same thing. So it basically means here, because we have that thing, we have in our mind to say we have altered with a what? With a theta there, or the t in this case, which is our angle. So it basically means our cos, we're going to say, instead of saying cos 2t, I'm going to say it's going to be cos what? Cos 6 what? Cos 6t. Okay, so it's more like you multiply the coefficient of t that you're supposed to have initially, like you're supposed to have cos 2t. So the coefficient of the angle, which is the 2, multiplied by what you have here, which is a 3, giving us a what? Giving us a 6. So this could have been equals to cos squared 3t minus sine squared 3t, like that. So here you just make cos, from this Pythagorean identity, you just make cos squared 3t the subject of the formula, then you substitute here, you're still going to arrive at this destination. Okay, and that is basically what we want to use. That makes that makes integrating what we have there interesting and very easy to go with. So it basically means here we are all going to say all we are going to say is that instead of having this, we're going to substitute this with what? 1 over 1 minus cos 6t divide by 2 dt there. Okay, so here I can write these as individual integrals, or I can just say 1 over 2 minus cos 6t here divide by 2 dt. So you observe to say if you integrate this part, Okay, it still remains as 1 over 2. You just add a t there minus. So this part is going to, the integral of cos is sine. Okay, so how do you come up with this? I've talked about this in most of the videos. It's like here you're going to have a sine, sine theta here. Here you're going to have cos what? Cos theta. You're going to have minus sine what? Sine theta. Here you're going to have minus cos what? Cos theta here. So what it is that if you differentiate sine, you know that you're going to get a cos. Okay, if you differentiate cos, you're going to get minus sine. So what it means is that when on this kind of like I would call it a plus or something. So when you're going in the anti-clockwise or counterclockwise direction, what you're doing is that you are differentiating. When you go clockwise, like you go in this direction, you are integrating. So the integral of cos is sine. Okay, so here you're just going to have what? Sine 6t divide by, am I going to say divide by 2? The answer is no. So the thing here is that we're also going to divide by the derivative of the angle. So the derivative of the angle that we have there is what? Is so it's more like you have something like how can I put it? Mm, it's more like you are saying y is equals to 16. So your dy is going to be equals to 6 what? 6 dt. So the derivative that you have is what? Is a 6. So you're going to divide by that. So you're going to say divide by what? Divide by 6. So you have a 2 there. So in simple terms, this is just going to be a 2 multiplied by 6, of which we know that is a what? That is a 12. Okay, so that is basically what you get as the integral. If we want, we can simplify this and leave it as we can say, since we have over 1 over 2t there minus sine 6t divide by 12, we can put a 12 here. Okay, so this is going to be that's going to be 6t minus um, minus sine 6t there, like that. Okay, so that's simply how you come up with the integral of that. Don't forget to say the main aim for this video is just to remind us about the importance of some trig identities when it comes to integral calculus, and in this case we are talking about the double angle identities, which are very critical when it comes to integration. It might not only be the second one, you might find questions that require you to use the third one, which is this one, or the first one, which is that one there. So it all depends on the angles that you have. The angle that you have right here, the angle that you have right here, it just depends on the angle that you have on the other side. As it changes, you just multiply the coefficients. It's going to give you the what? The desired angle that you're supposed to use. That's all in this video. Thank you very much for watching.